We inhabit a galaxy known as the Milky Way, which contains hundreds of billions of stars. How did we arrive at this point, and what is our future? These concerns involve galaxies in every aspect. The known universe contains 200 billion galaxies, each of which is unique, immense, and dynamic. Where do galaxies come from? How do they work? What is their future? And how will they die? If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. This is the Milky Way, our galaxy. Approximately 12 billion years old, the galaxy is a vast disk with enormous spiral arms and a central nucleus. It is only one of countless galaxies in the universe. Galaxies are massive assemblages of stars first and foremost. A typical galaxy could contain 100 billion stars. They are actually stellar nurseries, the locations where stars are formed and perish. The stars in a galaxy are formed in nebulas, which are concentrations of dust and gas. Our galaxy contains billions of stars, many of which have planets and moons orbiting them. But for a very long time, we knew very little about galaxies. A century ago, we believed that the Milky Way was the only galaxy in the universe. In 1924, astronomer Edwin Hubble altered the entire situation. Hubble observed the universe using the most sophisticated telescope available at the time, the 100-inch Hooker on Mount Wilson near Los Angeles. Far, far away, he saw hazy masses of light in the darkness of the night sky. He realized they were not even separate stars. They were entire star-filled cities, constellations far beyond the Milky Way. The astronomers received an existential jolt. We went from the Milky Way galaxy being the only galaxy in the universe to billions of galaxies in a single year. Hubble made one of the finest discoveries in the history of astronomy when he discovered that the universe contains a large number of galaxies rather than just one. This is the Whirlpool Galaxy. It comprises over 160 million stars and is characterized by two enormous spiral arms. In addition, the stars of the huge elliptical galaxy M87 shine with a golden hue since it is one of the oldest galaxies in the cosmos. And this is the Sombrero Galaxy. Its massive bright core is surrounded by a cloud of gas and dust. All galaxies are very beautiful. They stand in for the fundamental building block of the cosmos. As they spin across space, they resemble enormous pinwheels. Galaxies are enormous on a grand scale. On Earth, we measure distance in miles. In space, astronomers use light years. This is how far light can travel in a year. Our galaxy's diameter is over 100,000 light years, and we're now located at a distance of 25,000 from its center. However, in the grand scheme of things, even it seems like a tiny dot. While the Milky Way seems enormous from Earth, when compared to other galaxies, it is really rather little. Andromeda, the galaxy closest to us, is about 200,000 light-years wide, making it twice as large as the Milky Way. M87 is the largest elliptical galaxy in our own cosmic backyard and much bigger than Andromeda. But M87 is tiny compared to this giant. 6 million light-years across, IC1011 is the biggest galaxy ever found. It's 60 times the size of our own Milky Way. It's common knowledge that galaxies are enormous and ubiquitous. But why is this the case? The origin of galaxies is a key mystery in astrophysics. Approximately 13.7 billion years ago, the universe began with what we refer to as the Big Bang, a period of intense heat and density. We know that there could not have been anything like a galaxy at that time. So galaxies must have come from that very early universe and formed from it. For stars to form, and for galaxies to form from those stars, gravity is essential. After the Big Bang, the first stars began to emerge only 200 million years later. The earliest galaxies formed as their masses began to clump together because to gravity. Thanks to the Hubble Space Telescope, we can now see the early universe when galaxies were just beginning to form. Numerous galaxies are visible to the Hubble, the light we see from distant galaxies now. However, really departed those objects many millions or perhaps billions of years ago. What we see now is the distant past of those galaxies since it took so long for their light to get to us. The Hubble Deep Field reveals a collection of fuzzy dots. They are quite different from the galaxies we see now. We can hardly make out these little specks of light. Those fuzzy patches of light are really millions or billions of stars beginning to combine. The oldest galaxies are represented by these barely visible blotches. They began to take shape around 1 billion years after the Big Bang. However, Hubble's range of visibility ends there. A second sort of telescope, one too large to send into space, is required if we are to travel much farther back in time. Not only can the telescope identify primordial galaxies, but it can also trace their evolution. The evolution of galaxy and galaxy cluster formation may be followed. All the galaxies that have developed since the cosmos was just a few 100,000 years old are leaving their imprints for us to observe. Finally, scientists can begin to answer the question, what did young galaxies look like? Galaxies have evolved from clusters of stars to the complex web of systems we see today, and this process is being seen by astronomers. As far as we can tell, the greatest structures in the universe today originated as star clusters, evolved into galaxies, formed clusters of galaxies, and ultimately coalesced into superclusters of galaxies. There was a lot of stardust, gas, and clumpy structures in the early galaxies. However, modern galaxies seem organized and tidy. When and how can tangled clusters of galaxies become neatly organized spirals and pinwheels? Gravity is the explanation. Galaxies are molded by gravity, and its effects determine their fate. At the center of most galaxies lies an unfathomably strong and destructive gravity source. And our own Milky Way has one hidden at its core. Over 12 billion years have passed since galaxies first appeared. These stellar conglomerations may take many forms, from spirals to giant spheres of stars, as far as we can tell. However, there is still a great deal we don't understand about galaxies. How did galaxies evolve into their present forms? Did spiral galaxies always have to be spirals? The answer is almost certainly no. Young galaxies are a mix of stars, gas, and dust. They are untidy and chaotic. They begin as chaotic formations, like the Whirlpool Galaxy, then over billions of years develop into more orderly forms. The Milky Way wasn't born from a single galaxy, but from a cluster of several. Our Milky Way originated as a collection of disparate formations, objects of varying sizes and shapes that gradually merged to become the galaxy we see today. Gravity is what binds the various components together. Over time, it gradually draws stars closer. They pick up speed and flatten out into a disk shape. Massive spiral arms gather stardust and gas. This process was carried out countless times during the course of the cosmos. While visually distinct, these galaxies share the fact that they all seem to circle the same central object. For a long time, researchers pondered what might possibly alter a galaxy's behavior. And they found out: a black hole. And not just any kind of black hole, but it's a supermassive black hole. The discovery of extreme amounts of radiation coming from the centers of certain galaxies was the first indication of supermassive black holes. Black holes in these galaxies are eating their surroundings, much like a giant Thanksgiving feast. The gas and stars are the supermassive black hole's dinner. Sometimes black holes consume their food so rapidly that they spew it out into space as beams of pure energy. They refer to it as a quasar. The presence of a quasar indicates the presence of a supermassive black hole at the center of the galaxy. However, what about the Milky Way? There's no quasar here. Does it rule out the existence of a supermassive black hole? Observing the motion of the stars is the key to finding the supermassive black hole in the heart of our Milky Way. Like the planets that circle the sun, the stars also move due of gravity. What we discovered was a bizarre and violent environment. At the center of our galaxy, everything is more extreme. Things move very quickly. The stars will be passing one another at high speeds. It is unlike any other place in the universe. The photographs of the stars in orbit showed a remarkable phenomenon. They had to have been traveling at 1,000,000 miles per hour or more. Only a gigantic black hole has the energy to toss large stars around like that. This curvature was the conclusive evidence for a supermassive black hole at the heart of our galaxy, as it is the black hole's gravity that drives the orbits of these stars. A massive black hole measuring 15 million miles wide sits at the heart of our Milky Way galaxy. So, is there any danger to Earth? We are in absolutely no danger of being sucked into our supermassive black hole. It's simply too far away. In reality, the distance between Earth and the supermassive black hole in the heart of the Milky Way galaxy is 25,000 light years. That's many trillions of miles. For the time being, Earth is secure. Although supermassive black holes are the source of enormous quantities of gravity, they are not strong enough to bind galaxies together. In reality, the rules of physics dictate that galaxies should accelerate away from one another. So what's stopping them? Because there's something stronger than a gigantic black hole waiting to be discovered. It is invisible and very difficult to detect. It's called dark matter, and it's everywhere. Supermassive black holes discovered by astronomers are found in the centers of galaxies and are responsible for the rapid movement of stars in their vicinity. However, they are insufficient to hold together all of the stars in a vast galaxy. So what does hold them together? It was a mystery until a maverick scientist proposed that something unknown was at action. Fritz Zwicky, a Swiss astronomer, pondered in the 1930s why galaxies clustered together. He reasoned that because they weren't producing enough gravity, they should be flying apart. However, the force of our own gravity was insufficient. Therefore, he deduced that it must be something that had never been discovered before, something that had never even been considered, and he called it dark matter. Fritz Zwicky was decades ahead of his time, and that's why he grated on the astronomical community. And this is a brilliant idea. But he was correct, you know. It's possible that individual galaxies are also held together by the mysterious substance that Zwicky dubbed dark matter. Galaxies rely on dark matter as a kind of protective framework that keeps them from collapsing and moving about. Now, scientists have discovered that dark matter does more than just bind galaxies together. It may have also triggered their evolution. Scientists believe that after the Big Bang, dark matter started to cluster, and these dark matter clumps evolved into the galaxy's nucleus. However, the nature of dark matter is still a mystery to physicists. Weird things happen with dark matter since we don't know what it is. Obviously, it's not constructed from the same substance that humans are. You can't push against it. You can't feel it. However, it is likely everywhere. It's a ghost-like material that will pass right through you as if you didn't exist at all. Although our understanding of dark matter is limited, it seems to be abundant across the cosmos. That means there must be at least 6 times as much dark matter as regular matter, what humans are comprised of in the cosmos. And the way the cosmos seems to function depends on it. Observations of its effects on light have led to its recent indirect detection in deep space. Through a process known as gravitational lensing, it warps the light. The existence of dark matter may be tested using gravitational lensing. As a ray of light from a distant galaxy travels towards us, its course will be bent around a huge collection of dark matter due to the latter's greater gravitational attraction. Some distant galaxies indeed seem stretched and warped when seen via the Hubble telescope. The picture distortion is due to the presence of dark matter. We can determine the density of dark matter by carefully examining the forms and degrees of distortion of these galaxies. Now more than ever, the importance of dark matter to the cosmos is undeniable. It's what makes galaxies form and stops them from collapsing. Even though it's invisible and undetectable, dark matter rules the cosmos. These galaxies seem to be completely alone. It's true, they are trillions of miles apart. But actually, they live in groups called clusters. And these clusters of galaxies are linked together in superclusters, containing tens of thousands of galaxies. The Milky Way's place in the cosmos remains a mystery. If you look at the overall image, you'll see that our galaxy is associated with a smaller group of galaxies, including about 30 members in total, and that our galaxy and Andromeda are the 2 largest members of this group. Further observation reveals, however, that our galaxy is embedded inside the Virgo supercluster. Researchers are now making maps of galaxy clusters and superclusters to better understand the cosmos. Galaxies are the immense star empires. The shapes range from enormous balls to intricate spirals. The problem is that they are always evolving. When we stare out into the cosmos, it's easy to assume that our galaxy hasn't changed in eons. It's not. The Milky Way is a dynamic galaxy. Over cosmic eons, its basic nature has been changing. Galaxies don't only evolve, they move as well. And sometimes they run into each other. The 2 galaxies will merge over millions of years when they collide. This kind of collision occurs all the time in the cosmos. Our own Milky Way is no exception. We are on a collision course with the galaxy Andromeda, and that's terrible news for the Milky Way. At a speed of around 250,000 miles per hour, our Milky Way galaxy will collide with Andromeda in about 5 billion to 6 billion years. It's all over for the Milky Way galaxy. If you could look out into space, you'd see the whole Andromeda galaxy hurtling toward us, at a tremendous rate of speed. As the two galaxies interact, they both become more and more disturbed and closer together. There will be a dance of death between the two galaxies. Whenever galaxies collide, they release clouds of gas and dust in all directions. As galaxies collide, their combined gravity rips stars from their orbits and launches them into the void. As we approach doomsday for the Milky Way galaxy, it would be spectacular. The two galaxies will ultimately pass through one another and merge into a single one. The Milky Way and Andromeda as we know it will cease to exist, and Milkomeda will be born, and it will look like a whole new galaxy. There's no escaping what's going to happen. The question is, what's it mean for planet Earth? We may either be thrown out into outer space when the arms of the Milky Way galaxy are ripped apart, or we could wind up in the stomach of this new galaxy. Stars and planets will be pushed all over the place, so this may well be the end of planet Earth. Galaxies all over the universe will continue to collide. But this age of galactic cannibalism will eventually pass, because there is an even more destructive force in the universe, a force that nothing can stop. It will eventually tear the cosmos apart by stretching everything to the point that galaxies are pushed apart from one another. Researchers have identified a new cosmic power. It's called dark energy. Unlike dark matter, dark energy has the opposite effect. It pushes galaxies apart rather than bringing them together. Dark energy, which we've only discovered in the last decade and which dominates the universe, is significantly more enigmatic. We don't have the slightest idea why it's there. What it's made from, we don't really know. We are aware of its presence, but beyond that, our understanding of it is limited. Dark energy is really weird. Things resist and are pushed away from one another as if space itself contained tiny springs. In the far future, scientists predict that dark energy will triumph over dark matter in the cosmos. And with that triumph, galaxies will finally begin to drift apart. Galaxies will eventually die off due to dark energy. It will do this by accelerating the expansion of the universe, forcing all galaxies to recede farther and further away from us until they become invisible and travel faster than the speed of light. Therefore, everything else in the cosmos will vanish before our own eyes. The remainder of the cosmos won't vanish today or tomorrow, but it may after 1 trillion years. Galaxies will be left alone in the void. However, this will not occur for an extremely lengthy period. The cosmos is doing well right now, and galaxies are creating favorable circumstances for life to exist. Without galaxies, I wouldn't be here. You wouldn't be here. Maybe not even life itself would exist. This is fortunate for us. The only reason why life has evolved on Earth is because our minuscule solar system was formed in the correct region of the galaxy. If we were any closer to the center, we wouldn't be here. Life in the center of a galaxy may be extremely hazardous. In point of fact, the proximity of our solar system to the core of our galaxy would render it so radioactive that it would be impossible for life to continue in any form. Too far away from the center would be just as bad. Out there aren't as many stars. We might not exist at all. We are therefore, in a sense, in the Goldilocks zone of the galaxy, neither too close nor too far away, but just right. There may be millions of stars in the cosmic Goldilocks zone, where conditions are just suitable for life. Furthermore, if our galaxy can support life, then other galaxies should be able to as well. The cosmos is very large, and the really incredible part is that we continue to learn new things about it. Every time we believe we've figured out a solution to an issue, we uncover that it's really part of an even greater one. That's awesome. Our Milky Way galaxy and the galaxies beyond it are rife with mysteries and unanswered questions. Who would have guessed 20 years ago that we would be able to identify the black hole at the center of the galaxy? Who would have predicted 20 years ago that the astronomical community would accept the existence of dark matter and dark energy? We should be astonished to be alive at this particular moment in cosmic history, on this particular planet, on the fringes of this particular galaxy, with the ability to ponder questions and seek answers across the whole cosmos. Galaxies are born, they evolve, they collide, and they die. The Milky Way is a fortunate home for intelligent life. Our fate is intertwined